Geometry, Unit 6, which is Chapter 4 from the book, Section 7, Flowchart Thinking. Flowchart thinking, the idea of a flowchart is to make the logic visible so that others can follow your reasoning. To present your reasoning in a flowchart, create a flowchart proof. So the idea is you fill in information, those combine into one statement, which leads to another statement, and then you got another separate thoughts going down here. Eventually, these two combine into what we're trying to prove. That's the whole idea behind flowchart thinking. It's a very visual representation. Now, we've been doing this idea of logic, using logic to step out one thing to the next, using two-column proofs. But this is a more visual approach to it than two-column proofs. So we're going to do the same thing we've been doing. So in this figure, we're given EC is congruent to AC, and then we're also given ER is congruent to AR. And we're going to find out, is angle E congruent to angle A? So we've got AR equals ER, EC equals AC, and then we're going to say RC equals RC. Now, I don't need to go through the reason why I can say RC equals RC in this particular example, but we know it's true because of the reflexive property. Now, all of these three prove the triangles are congruent. This proves the triangle REC equals the triangle RAC. We know that because of side, side, side. This then tells us angle E equals angle A because of corresponding parts of congruent triangles are congruent. So we got reflexive here. I'll fill it in. Here we've got side, side, side. And then we've got corresponding parts of congruent triangles are congruent. So it's a little bit easier than two-column proofs. That's a little bit more visual representation. Okay, same figure, but we now got some different information. Angle CRE is congruent to CRA. ECR congruent to ACR. Is EC congruent to AC? Well, we know RC is equal to RC. These three prove that the two triangles, triangle REC is equal to triangle RAC. We did that by angle, side, angle. And then through corresponding parts of congruent triangles are congruent, we prove EC is equal to AC. So let's look at one more example here. AC is congruent to CD. BC is congruent to EC. And the question is AB equal to DE? Well, we know vertical angles are congruent, so we can say angle ACB equals angle DCE. Again, that's vertical. So all three of these give us triangle ACB is equal to triangle DCE. And then, so that's side, angle, side. And then corresponding parts of congruent triangles are congruent. That tells us AB is equal to DE. And that is the end of our lesson.